Example number 4 is going to look at creating a grouped frequency distribution. So we have a data table that has record high temperatures in degrees Fahrenheit for each of the 50 states. And it wants us to construct a grouped frequency distribution and a grouped relative frequency distribution for the given data using 7 classes. So as we previously talked about in our vocabulary, we are going to need to figure out what the class width will be. And the way that you figure out what your class width will be if you have data is you need to figure out what your highest value is, what your lowest value is, and then that will help you to determine what the class width needs to be. So for our data here, our highest value is 134, and our lowest value is 100. So to find the class width, we are going to take our maximum value minus our minimum value and divide by the number of classes we want. Here it told us to use 7 classes. So our class width here is going to be 134 minus 100 divided by 7. And when we do that, we get 34 divided by 7, which is about, not 3, 4.8. And so we're going to round up. We're going to make that 5. So our class width will be 5. And I'm going to start my lower class limit at 100 for my first class. So in my frequency table under classes, LCL stands for lower class limit, and I'm going to put 100 in there. And then I'm going to use my class width to get this next one. 100 plus 105 plus 5 gives us 105. 105 plus 5 gives us 110. 110 plus 5 gives us 115. 115 plus 5 is 120. 120 plus 5 is 125. And 125 plus 5 is 130. Now that I know what my lower class limits are, I can figure out what my upper class limits are. And just remember that from one lower class limit to the next lower class limit is what we call our class width. So here we were adding 5. That is our class width. Sometimes students get confused and they'll think that the class width is the distance from the lower class limit to the upper class limit. So we don't want classes to overlap. So we don't want 105 to be able to be in both the first class, which is the first row, and the second class, or that second row. And so as a result, we're going to make the first class go from 100 to 104. And for the next one will go from 105 to 109. Notice from 104 to 109 is plus 5. The next one's going to be 114, and that's also plus 5. So you can either look at the lower class limits and find your class width, or the upper class limits to find your class width. We'll go to 119, 124, 129, and then 134. Class boundaries is the distance in between, or really the middle in between the different classes. So what is between 104 and 105? So the way that you find the distance between those two is you go in between them. So halfway between 104 and 105 is going to be 104.5. So I know my upper class boundary is 104.5. And then for the next class, my lower class boundary is going to also be 104.5. And the upper one will be 109.5. And then 109.5 to 114.5. And 114.5 to 119.5. 119.5 to 124.5. And 124.5 to 129.5. And 129.5 to 134.5. And we can go back to the beginning, and our lower one would be 99.5. Once we have our class boundaries, we can use either the boundaries or the lower class and upper class limits to help us find class midpoints. Midpoints are halfway in between. So if our lower class limit is 100 and our upper class limit is 104, the midpoints are going to be halfway between there. So a way to find it is you can average the upper and lower class limits. So we can take 100 plus 104 and divide that by 2. And when we do that, we end up with 102. You could keep doing that over and over, but you don't need to. The class width is going to follow those class midpoints. So we're going to have 102, and then add 5 to that, we'll get 107. Add 5 to that, we get 112. Then 117, 122, 127, and 132. All of these things are not required for a frequency table. A frequency table requires you to have the classes, so the lower class limit and the upper class limit, and then also your frequencies. So this column here, this is our frequency. And this one is going to be the relative frequency. For our purposes of our notes, I put all of them into one big table so that we could talk about all of the different aspects, but the ones that are required for a frequency table are going to be this first column, and then one of these frequencies, whether it's a frequency table or a relative frequency table. The tally column is there simply to help you kind of organize your counting of the different values. So in my tallies, what I'm going to do is I'm just going to go through and I'm going to start in my first box. It says 112. And 112 would fall into this third class. So I'm going to put a tally there to help keep track. And then 110 also falls there. 107 is in the one before it. 116 is in the fourth one. Then 120, 100, 118, 112, and so on. 108, 113, 127, 117, 114, 110, 120, 120, 116, 115, 121, 117, 134, 118, 118, 113, 105, 118, 122, 117, 120, 110, 105, 114, 118, 119, 118, 110, 114, 122, 111, 112, 109, 105, 106, 104, 114, 112, 109, 110, 111, and 114. And that's just making it easier for me to be able to calculate what my frequency is. Remember that frequency is the total number of items that fall into each class. And each row in this table is known as a class. So we're going to have 2 that fall in that first one, 8 for the second one, 18 for the third, 13, 7, 1, and 1. And then relative frequency, we calculate relative frequency by taking our frequency and dividing by the total number of items. So our frequency for the first class was 2, and we have 50 items. 2 divided by 50 is 0.04. 8 divided by 50 is 0.16. 18 divided by 50 is 0.36. 13 divided by 50 is 0.26. 7 divided by 50 is 0.14. And 1 divided by 50 is 0.02.